image immediately, and they provide to the Japan the rescue organization. And this is another example. Because of time limitation, we can see that. So this is also the immediately we respond to the Japan, the aftermath tsunami right after the 1 day after. And again, the same. This is very famous damage on Sendai Airport. We also provide image very quickly, and did the same for this. This is the I wait, or sorry, I need to ask for Japanese friend how to pronounce that. The other one is just the we just mentioned in 2009, just 2 years ago, this typhoon Morocco have been killed more than 500 people in Taiwan, and because of our daily business and with our agility, so starting from August, actually this happened in August 8th. Because of weather condition, we start the image from August 10th, and we can continue coverage all the Taiwan, scan one line in Taiwan. And this is Typhoon Morocco, so that's just heaven, and you can see this is called Shaolin Village. There's a very 500 around 500 people in here. Okay. So this is the landslide area. You can see that. This is actually the image. They have it up to 10 meter thickness of the main site. Whole village originally in here, buried in here. Okay. So the other form of set 2, we have the limited image. This is really interesting to see that because we choose the 1 daily basis of it. Therefore, we are pretty high, about 90 kilometers high. And we also have field we got about 45 degrees. Therefore, we are one of very few satellites we can catch the South Pole or North Pole. This is the South Pole station. Okay, so this is a really interesting picture. And because of this unique object, therefore we supported international Quora years in 2007 to 2008. And this is the others, the platforms, because we're not satisfied with using the image only. We try to do is we try to the pilot projects, we integrate with other research laboratory with NEIL. We produce one 3D GS platform. We introduce most updated the Taiwan image plus some airborne image with very precisely digital terrain model. Okay. The other one that is still focusing on, this is one example of this a platform called Saber for the GMES. They do need a lot of time to do the service. In Taiwan and NSPO, we also consider this one because we have data to visit. So we can shorter the data providing time very quickly. This is the one example. I'd like to show you the Typhoon Morocco. We're using the 3D Taiwan GS Taiwan platform. We try to show is how to value edit on the remote sensing setup, not only for 3D model, because we have a lot of archive data. Therefore, when the decision maker or rescue, they are going to evaluate or make assessment for aftermath of the major disaster. It's very interesting. We can use this kind of model to compare what is before and the after. Okay, this is an example we are using. We also apply for Japan as well. Because the time limitation, we just step one. So the following mission will be the formal set 5. So I think we already mentioned about the NSPO remote sensing mission. I think formal set 5 is more significant to Taiwan. Not only remote sensing data itself, but this is first intelligence. We make it ourselves program in Taiwan. So this is system architecture with the performance pretty similar to formal set 2. However, we still keep the resolution on 2 meter. However, we're increasing the 4 meter for the multispectrum. Here is very unique for Taiwan. We make a system trial. Because we need to consider the GSD, we had to consider the manufacturing and design capability in Taiwan, and we had to consider the budget and the schedule. And therefore, I think we only can do if your system engineer is compromising. We are not designed to the cost. We are not designed to the performance. We are designed to the best performance to Taiwan. So we still keep the mission profile on the data delivery capability. This time we choose 1.5 in 720 kilowatts on synchronous orbit. Again, we try to do is to put the performance at 5 in this orbit, and we can duplicate it very quickly if we launch it to some performance at 5. We are planning to put it in this orbit. Therefore, we would go back to the data delivery capability, and with better than formal set 2 is global coverage as well. This one just show you the orbit. And next one we try to do is because we not so many remote sensing satellites, so we try to do is improve the agility performance of formal set 5. Originally, we can see most remote sensing satellite they can perform is the around track image. We try to do we can make it is such as we can make the state longitude and also the along the cost, such that we can save more time. I have one more 100 page to present, but okay, I'll try to run it quickly. And the others I would like to mention is the ISI. ISI is the most important payload. This time we do it called ITA-free approach, actually 100% made in Taiwan. And this is a domestic team, and this is the remote sensing instruments we have built. Okay, this is the image we try to do. We traditionally most satellite using the CCD image. We try to do is we're using the CMOS image because CMOS is very important. It's one of industry competence in Taiwan, also in the world, because of time limitation. They turn off the computer as well. So, I'm sorry, I promise I'll finish in next 3 to 5 minutes. Next we then talk about the radio occultation. Okay, everybody know the format 3 very well. Radio occultation, they provide. This technology actually is by definition remote sensing technique as well. They're using the GPS receiver onboard spectra to receive GPS signal from the bending angle, such that they can retrieve the water vapor, temperature, and pressure over time. And this is has been phrased as the most accurate thermometer in space. They call it format 3. And currently, I think this we didn't update it. This is already over 60 countries, more than 1,600 people using that. I think I skip this chart. I also skip this chart. I also skip the chart. I would like to mention this chart, how effectiveness of GPS radio occultation data. This is the data have been provided by ECMWF. It's been ranked as the fifth most important data compared with all the space, the sensor data from space or from the airport. And also this is from the NASA about the impact of various observation. It's ranked 3. So with that kind of, this is the ECMWF to show you how the operational value against when they use this data since 2006. So lots of evidence to show that this data probably is very important for next generation weather for meteorological satellite. However, Bombardier 3 is getting old. It are going to provide a lot of data gap about that. So this is the why we have the Formosat 7 and called Cosmic 2. This program we are cooperating with the NOAA, actually not only NOAA and lots of agencies, including the NASA, Air Force, United States. And the I skipped the chart. This is system configuration. We are going to deploy. Actually, it's 12+1 satellite in 2 launches. One in 2015, the other 2017. And this is the cooperation between the mid spacelines. We are going to have 4 sets of the 6 spacecraft in low inclination angle, such as 24 degrees, and the other 6 on the high inclination angle, and 72. So we can provide 4 times of data, is as many as 8,000 data. Then then the Formosat 3 is provided only 2,000 in the launch period. So I think I don't want to emphasize how good for this kind of data. We want to emphasize is NSPO program. We always consider how to produce or how to enhance the societal impact as a necessary requirement for Taiwan Space Program. Okay, so my concluding remark with NSPO in carrying out the 2 major remote sensing the program. The Formosat 5 we would like to keep is maintains the daily visits features as well, and also the value added from the Taiwan industry is really important, and I believe this is the first one made by ourselves. We think we can make a success. And Formosat 7, I think, is very important to global users, such as weather prediction, climate monitoring, also space research study. And the second one, I think from remote sensing point of view, the synergy of remote sensing mission are very important through international cooperation mechanisms. 2 points very important is encourage the data sharing and the mission alignment, especially at the regional level, such as Asia. And also value add on the service mechanism is very important, because we not only sell the image itself, we have to have one mechanism, end-to-end service to the customer. That's very important. And next one, I think this is redundant. We try to make NSPO as a space, as excellence centers, and also innovation for space technology in Taiwan. Thank you for your attention, and sorry.